If you start thinking about a single survey ship out there, and then you think, well, what if that survey ship has 2 small launchers, and what if those 2 small launchers had 4 drones each? Well, now all of a sudden you've got a survey capability that's 10 times bigger than the original and traditional concept. So autonomous vehicles really gives us this ability to survey potentially 10 times as much as we traditionally would. So that brings a challenge as well. If you've got 10 times the data, you've got 10 times the processing bottleneck. So the need to, automate, take and do that automatically, put the human over the loop rather than in the loop, that allows you to start seeing how you could address that challenge.
So there's kind of 2 things we're trying to hit with on when we designed Onboard. One of them is that we wanted to work not just for a standard survey where you have 1 or more people out on a boat. We wanted this to apply well to autonomous vessels or boats which maybe don't have a full staff on board, people who are trained hydrographers or knowledgeable enough to understand what they're looking at. So we took a really unique approach in designing Onboard, where we built it around a web service. And so what that does is it allows the information that's being processed on the vessel to be easily and readily accessible for somebody who's not on that vessel. And not on the vessel could mean that you're standing 100 meters away from an autonomous boat driving it with remote control on the beach, or it could be a trained hydrographer who's back in the office monitoring 5 or 6 vessels, which could be anywhere on the globe. Just so long as there's some kind of network connection between that person who has training and the vessel, they're able to keep an eye on the survey and identify anytime there's a problem that comes up, and then they can communicate the changes that need to happen back to the crew.
The fact that in today's world data volumes are increasing, so the sensors are getting higher and higher resolution, which means we're getting more and more data points. The sources of data are becoming more widespread, so we think of traditional sources like the survey vessel, the multi-beam sonar, but then we can start to think about crowdsourced information and satellite-derived information. So the data densities are going up because we've got a greater number of sources and higher resolutions, and that just compounds the need to reduce that ship-to-shore turnaround time because we're extending it in the traditional sense. The other aspect, and related to the crowdsourcing aspect, is more non-traditional platforms are being used to acquire data. So, for example, if we think about a Canadian example, non-survey vessels are up in the Arctic, sailing through the Northwest Passage. They've now got sensors on board, but not necessarily the expertise to operate those sensors. So if we put CARIS on board, where we don't have an expert or a hydrographer on board, and monitor that from an office to the south, then we can seek the benefit of having this armada of vessels up there collecting data without the expertise necessarily there in the field. So this is kind of one of the direct advantages of Onboard over traditional post-processing software.
So another unique design aspect to Onboard is when we built these web services, we wrap them all in an API. And what that means for users is that they can take our system and they can embed it into their own setup. They don't have to use our front end or our controls. If they already have a software package that they've developed for controlling their autonomous vessel, they can embed Onboard into that system and have those products and information displayed within their own software.
And I think that becomes amplified when we think about one of the hot topics at the minute, which is mapping the world's oceans, and we think about Seabed 2030, this idea of having higher resolution bathymetry survey data for the entire world's oceans. In order to cope with that hose pipe of data, really this huge pipe of information that's flowing so that we can populate that global data set, we're really going to need automation techniques and processing that can meet the needs of the time demands that kind of initiative suggests is required. So I think CARIS Onboard and the technologies that we're putting into Onboard are going to help us meet those challenges. And I think, the fact is we've got highly professional people in hydrographers, and if the computer does what it does best, which is automate the non-subjective, repeatable pieces, then we can leave the professionals to do the hard stuff. And I think that's a really good use of their time. So yeah, if you can't have a hydrographer on board, put CARIS on board. So as we see the AUV market and autonomous vehicle market growing, and really that's a trend that's mirrored on the UAV side, on the airborne drone side, we feel we're well situated at Teledyne CARIS to address that. We've got 40 years of data processing and digital mapping expertise, and I think that wealth of experience can be applied to the challenges around automation and autonomous vehicles. And so we're uniquely positioned actually to provide this CARIS Onboard real-time data processing toolkit.
So one thing that I can tease is that we're putting a lot more work into the amount of processing that you can automate and the amount of tasks that can be automated during the survey. And what that means is when the survey is finished, it's we're getting to a point where there's even less and less processing that the data processors will have to take on themselves to get to a final product. So really it's by moving more of the processing into the automated real-time realm, we're going to be able to reduce efforts required for a survey and the amount of time that it takes to go from survey to the final product that you can deliver to your customer. So really the biggest reason that I see that you need onboard in your workflow comes down to basically saving money in your operations.